Hey guys, today we're going to do the transformation called a rotation. But first, we need to check your homework from Friday, which was reflections. So go ahead and take out your papers from Friday. And if you were absent, right now you need to pause this video and get up and go to the back of the classroom and get a notes page for reflections out of the Friday folder in the back of the room. So if you were absent, get up and do that right now. You can pause the video. If you're present, you should be taking out your paper right now. So I'll give you guys a few seconds to locate your homework so that we can kind of go over it and make sure you're good on reflections. All right, so let's get started on reflections. So for the first practice, number 5 says reflect over the x-axis. And it wants us to give the coordinates of the original and the image. So let's start with the coordinates. So I notice that I'm going to go in alphabetical order here. Point E is at -1, 2, 3, 4, and up 1, 2, 3, so +3. And point F is at -1, left 1, up 4, +4. Let me just double count. 1, 2, 3, 4. Yes, +4. And point G is at +1, 2 to the right, and up 1, 2, 3, +3. And last point H is at left 2, so that'd be -2, and up 1, +1. All right, so now I want to find the image, so I got to use my rule, which for reflecting over the x-axis is that x stays the same and y becomes its opposite. But since they give us a coordinate graph, we can do it graphically too. So let's try that first. So we're going to put our pencil on point E, and we're going to go to the x-axis, which is your horizontal axis, the one here, and we're going to count how many spaces it takes us to get from E to the horizontal axis. So we count 1, 2, 3, and we're going to do the same amount of spaces in the opposite direction, 1, 2, 3, and this will be our new point, so we label it E prime. Do the same thing with F. Count to the axis X, because that's the one we're reflecting over. 1, 2, 3, 4. And do the same amount in the opposite direction. 1, 2, 3, 4. Draw your point, label it F prime. G, 1, 2, 3 spaces away from the x-axis. 1, 2, 3 spaces in the other direction. G prime. And H, 1 hop to the x-axis and 1 hop away. Label it H prime. Connect our points. And there it is. So now let's just list our points. So E prime is at left 1, 2, 3, 4, down 1, 2, 3. So -4, -3. Notice it goes with our rule that x stays the same. -4 stayed -4, and y became its opposite. The 3 became a -3. So a shortcut could be just to apply the rule, or you could count each time. So I'm going to start using the rule to rewrite. So x stays the same. So for F prime, -1 stays the same, and 4 become -4. So just to double check, left 1, down 4, that works. G prime, the 2 will stay the same, the x value, and the y will become its opposite, -3. And just to double check, right 2, down 3, there it is. And H prime, we will go, let's do the rule. -2 stays the same, and then 1 will come its opposite, which would be -1. Double check that. Start at 0, 0, left 2, down 1, and there it is. All right. Now let's practice over the y-axis. So for the y-axis, we have this figure here, JKLMN. So the y-axis is your vertical axis here. So we're going to start with J, and we're going to count how many hops to the y-axis. So 1, 2, 3, 4, 5 hops. So we'll go the same amount in the opposite direction across the y-axis. 1, 2, 3, 4, 5. And label it J prime. Okay, 1, 2, 1, 2. K prime. L, 1, 1 away. L prime. M, 1, 2, 1, 2. M prime. And N, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. N prime. All right. Kind of went through my letter K there, but that's okay. I should have wrote it on the outside a little more. All right, let's list our coordinates. So for J, we were at negative 1, 2, 3, 4, 5, and up 4. Negative 5, positive 4. For K, it is at negative 2, positive 3. This one's a little easier because it has the numbers on the graph. This one's negative 1, positive 1. L, that's not L prime, it's just L. So let me erase that. L is at negative 1, positive 1. M is at negative 2, negative 2. And N is at negative 5, 1. So now we're going to list our new coordinates for the image that we made, and we can also use our rule for flipping over the y-axis. The x value becomes its opposite and the y value stays the same. So for J prime, the x value becomes its opposite, so negative 5 became positive 5, and 4 stayed the same. And just to check, we can see that J prime is at 5, right 5, and up 4, and there it is. All right, K prime, the x value becomes its opposite, so negative 2 became positive 2, and 3 stays the same. So on K prime, we start at 0, 0, right 2, up 3, there it is. L prime, the x value becomes its opposite, so negative 1 became positive 1, and the y value stayed the same as a 1. So at 1, 1, we should see L, and we do. For M prime, the negative 2 became a positive 2, it's opposite, and negative 2 y value stays the same, so let's try right 2, down 2, and there's M. And the last one, for N prime, we are going to do negative 5 becomes a positive 5, and the 1 value, the y value of 1 stays the same, so it should be right 5 and up 1, and there it is. So there's those. Okay, let's check the next page. All right, for these, here we go. We're going to do the same thing. So we're reflecting again across the y. So we're going to count how many spaces it takes to get to the y-axis. So start with C, 1 hop, so 1 hop in the other direction. Then go to Z, 1 hop in the other direction. And I should be labeling these prime, which looks like they kind of already had an apostrophe, but that's okay. And then L, 1, 2, 3, 1, 2, 3. So that would be L prime. All right, connect it, and there's my new triangle. And the original coordinates for C would be 1, 4. And the new coordinates for C prime are negative 1, 4. And then for L, we can go right 1, 2, 3, up or down 0. And then for L prime, we went left 1, 2, 3, and up or down 0. And then for Z, the coordinates are right 1, left to right 0, and for Z prime, we went left 1, so that'd be negative 1, and up or down 0. All right, number 2, we're going to reflect across the x-axis. So take point A, and these have prime as well. So we're going to count to the x-axis, which is our horizontal here. So down 1, 2, opposite direction 1, 2, and label that. We'll just go with A for now. And then for L, count 1, 2, 3, 4, 1, 2, 3, 4, and that will be L. T, 1, 2, 3, 1, 2, 3. And M, 1, 2, 3, 4, 1, 2, 3, 4. All right, so it looks like this time we created the original and they gave us the reflection. So we'll write them accordingly. So for original, and if you did it backwards on your paper, you don't have to erase it and change it. You can just draw arrows. But for the original coordinates for A, since we're assuming that we just made the new one, I'm going to call this A. So left 1, down 2, so negative 1, negative 2. L would be left to right 0 and down 1, 2, 3, 4. So 0, negative 4. Let's move that out of the way. For T, it is left 1, 2, 3, 4, down 1, 2, 3. So negative 4, negative 3. And for M, it's left 1, 2, 3, 4, down 1, 2, 3, 4. So negative 4, negative 4. All right, for our new reflected, which they gave us, A prime is left 1 up 2. So negative 1, positive 2. And if you look at our rule, the x value stayed the same and y became its opposite. L became 0 up 1, 2, 3, 4. 0, 4. And then notice it was 0, negative 4. The y value just switched positions. So remember that our rule for the x-axis is x opposite y. All right, and for t was left 4 up 3. So negative 4, positive 3. Again, the x value stayed the same and the y value switched to its opposite. And the last one, m prime, was at left 4, up 4, so negative 4, positive 4. And I probably should have wrote those coordinates before I graphed, but that's okay. You can do it several different ways. Okay, for these problems, you were to fill in the blanks. So it said, when we reflect or flip an object across the y-axis, all the x's become their opposite, and the y's remain the same. So on your paper, I think this is called example A, and this is called example B. So just check your answers here. So you should have, for examples here, you should have let the x become its opposite, so 8 becomes its opposite, and the y value stays the same. So let's see if that is what we got here. So in this case, it became negative 8, comma, negative 2. So check your paper and see if you got that one right. And for B, you should get 5, negative 1. The x value changed and the y stayed the same. All right, the next set says when we reflect an object across the x-axis, all the y coordinates become the opposite and the x coordinates remain the same. So again, this is example A and B on your paper, I do believe. All right, so let's check our answers for these. You were reflecting across the x, so the x value stays the same and the y is the one that changed, so the second value becomes its opposite. So in 8, negative 2, the 8 stays the same and the negative 2 became positive, so you should have got an answer of 8, 2 for the new location. And for negative 5, negative 1, that one becomes negative 5, positive 1. All right, on the next set, you were to do the same thing. Some reflections across the x for the first 3. So remember that rule for the x-axis is x opposite y. So I'm going to write that. X opposite y. Always write your rule so that you can look at it and apply it. So for number 1, 4 stays the same and 1 becomes its opposite. So the new coordinates will be 4, negative 1. Number 2, negative 7, negative 3. And number 3, negative 8, positive 2. The negative 8 stayed the same and the negative 2 become its opposite, positive 2. All right, reflecting across the y-axis, our y-axis rule is negative x, positive y. So our y stays the same. So in the first example, 4, 1, the 4 is going to change to its opposite, negative 4, and the y value of 1 will stay the same. So the new location would be negative 4, 1. Number 2, negative 7 becomes positive 7, and 3 stays the same. So the answer is 7, 3. Number 3, negative 8 becomes positive 8, and negative 2 stays the same. So the new location is 8, negative 2. All right, for this bottom set, it says to reflect across the x and then the y-axis. And I'm missing the then, the n. So there. All right, so here we go. So first we're going to do the x-axis rule. So that will be our first rule. So I'm going to put number 1. We're going to do x stay the same, y change to its opposite. All right, so let's go through and do that first. So here, the 4 is going to stay a 4, and then 1 becomes negative 1. Number 2, negative 7 stays negative 7, and 3 becomes negative 3. And then 3, the negative 8 stays a negative 8, and the negative 2 becomes a positive 2. So all we did was reflect those across the x, but now we need to take that answer and reflect it across the y-axis. So this one was reflect across the x and then the y-axis. So now let's take our new answers and use our second rule, which is reflecting across the y-axis, which is opposite x and then y stays the same. So this time we're going to go through and change all the first values to their opposite. So this 4 and the first one becomes -4, and the -1 will stay the same. And that is our final answer. Number 2, the -7 becomes a +7, and the -3 stays the same. And that's our final answer, 7, -3. And then for number 3, the -8 becomes a +8, and the 2 stays the same. So our final answer is 8, 2. All right, so make sure you've checked your answers, and if you have any questions, you can let me know tomorrow or send me a message in It's Learning, and I will do my best to get back to you guys on those. All right, now we are ready to move on to our next transformation. It is our third transformation, and this one is called a rotation. So right now you want to pause the video and get up and ask the teacher, the substitute teacher, for the notes page for rotations. So pause the video or get up and ask the teacher right now. Pause the video and go get the notes page so we can fill it in together. And I'll give you a couple seconds to do that, and pause the video. All right, guys, so now you should have your notes page for rotations, and it starts at the top. You'll notice it has a little place for our definition, so we first want to fill that in together. And here it says a rotation is a transformation in which a figure is turned around a point. On your paper it says a rotation is a blank of an object around a point. So you want to put turn in that blank. And it says we will rotate our objects around the blank, and that's where we're going to put origin. And what is the coordinates for the origin? What should go in that blank? Yep, 0, 0. Okay, next I have a couple of things. Just a reminder about the quadrants. Remember last video, Friday, I gave you the little hint that if you can't remember your quadrants, you can always just take your pencil and draw a C, and that will help you to remember where your C begins. When we draw the C, that's your first quadrant. Then it moves into your second quadrant, and then it moves into your third quadrant down here in the bottom left, and then the bottom right is known as your fourth quadrant. So that kind of helps us, and we really need that for rotations because they can get confusing when we're moving from one quadrant to the other. All right, and then you see an example here, and it says the center of rotation, and that's right here. That's our 0, 0, and that's what we're going to be looking at always rotating around today is 0, 0. You'll notice that the original figure in this example starts up here in quadrant 2, and that's triangle ABC. And this triangle seems to be rotated first to the right one quadrant and became A prime, C prime, B prime. Now notice that it turned all the figures because A was here in the bottom, and now it's kind of to the left, and B was at the top, and it got kind of moved to the bottom here. So all the figures, the points move, but they stay in the same order. Your figure just rotates. Okay, and then from quadrant 1, it moved down to quadrant 4. And that's, I can tell because it has the double prime symbol. And notice that A's was started out in the bottom, then it went to the left, and now it's on top. Okay, and then once it rotated from quadrant 4, it went into quadrant 3, and over here, and I can tell that because it has 3 prime symbols on all the letters, and we need to decide which direction it went. So I would put a little clock on here that kind of helps you to remember that the hands on a clock go in this direction normally, which we call clockwise. So if you go clockwise on the quadrants, you would start in 1, go to 4, go to 3, and then 2, and back to 1. And that's the natural progression. But we don't always move in a clockwise direction when we're rotating. Sometimes they go counterclockwise, which would be the opposite direction. So if you started in quadrant 1 and you went in counterclockwise, you would go from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. So you need to make sure that you're clear on which direction is clockwise and which one is counterclockwise. Okay? All right, so now we have some rules that we can use to help us with rotations. And the rules are on your paper. They're in the table. So let's kind of go through these. It says a turn of an object around a point and will rotate around the origin 0, 0. So that's what you filled in your notes. So you should already have that. All right, so our rules are if we go 90 degrees clockwise for the X and Y values, okay? Now here's where it gets a little complicated, but don't be worried. We're going to get through it. there's a little switcheroo that happens here. The y value, you notice, is now written first. So this y value, whatever it is, it doesn't change. It just becomes in the first position. It becomes the new x. And then our x value moves to the second position and it switches to its opposite. So there's like a double switcheroo here. Also notice that 90 degrees clockwise is the same thing as 270 degrees counterclockwise. So if you were to go 90 degrees clockwise, so if you started at 12 o'clock and went to 3 o'clock, it would be the same thing as starting at 12 o'clock and going 270 degrees. You would wind up at 3 o'clock as well. Okay, so think about the clock each time you do that. All right, for our 180 degrees is completely turning around. So it's like going from 12 o'clock to 6 o'clock. All right, and that one's the easiest one. Our x and y, for our x and y values, they become opposite x and opposite y. You change both values to their opposites and then you don't have to do any switching. And if you go 180 degrees clockwise, it is the same thing as going 180 degrees counterclockwise. You end up in the same position. If you turn all the way around to the left and you turn all the way around to the right, it's the same thing. All right, the last one is 270 degrees clockwise, and that one, our rule is for xy, the y value then becomes first and its opposite, and our x value stays the same, but it moves into the second position. And there's a little hint down here that says first change the appropriate signs and then swap positions. So that's just a little hint. And 270 degrees clockwise is the same thing as 90 degrees counterclockwise. So it can get a little confusing. Once you do a little bit of practice though, and you've done several problems, it will get easier and easier. I do suggest coming back to this table and keeping this handy so that you can write your rules for each problem. All right, so let's do a couple of problems now. All right, the first one says rotate each point 90 degrees clockwise. So first let's write our rule for rotating 90 degrees clockwise. And if you look at your table at the top of your page or middle of your page, it says that our rule is y, comma, opposite x. So this tells us for 90 degrees clockwise that y is going to come, the y value is going to come to the front. So -3 and number 1 will come to the front. And then 8 is going to go to the second position and become its opposite. So 8 becomes -8 and it goes there. So the answer would be -3, -8. Number 2. All right, so -6. I'm going to go ahead and draw my parentheses and my comma. That kind of helps. So -6 is going to go into the second position and become its opposite. So -6 becomes +6 here. And -1 is going to go into the y position and stay its value. Number 3, the y value is going to come first. So 4 is going to come up here in the front. And -9 is going to go to the second position and change to its opposite. So that becomes +9. So the new point is 4, 9. All right, the second example says rotate each 180 degrees counterclockwise. So this time, 180 counterclockwise. Well, that's the easiest rule, my favorite. Opposite x, opposite y. You're just going to change both x and y to their opposites. So here we go. This one will be a lot easier. 8 becomes -8 and -3 becomes +3. Number 2, -6 becomes +6 and -1 becomes +1. So the new value is 6, 1. And the last one, go ahead and take a second and see if you can do that one on your own. All right, and number 3, -9 becomes +9 and 4 becomes -4. How'd you do? Awesome. All right, the last row is 270 degrees counterclockwise. So we go up to our table and find counterclockwise, the column that says counterclockwise, find 270, and you'll see that it's the same as our first rule. It's the same as 90 clockwise. So it's, again, y, comma, opposite x. So that means the y value will be moved to the front x position, and the x value, whatever it was, changes to its opposite and moves to the second value. All right, so let's see if we can do this. So I'm going to do my parentheses and my comma. That kind of helps. All right, so the 8 is going to go, let's move the 3 up. So -3 comes to the front and stays the same, -3. But the 8 becomes -8 and it moves into the y position. All right, so the new value is -3, -8. Number 2, I'm going to go ahead and do my parentheses and my comma. All right, so the -1 is going to come up to the front and stay the same, and then the -6 becomes its opposite, which would be +6, and it moves to the second position. All right, number 3, try this one on your own and see if you can get it. I'll give you a couple seconds. All right, number 3, so the 4 is going to move up into the X position. It's going to stay the same. So that's the Y value, so it comes to the front, and -9 changes to its opposite, so it becomes +9 in its second. So the solution is 4, 9. I'm sure you did great on that one. All right, let's do a couple in the coordinate plane. All right, so for these, I'm going to help you guys out a little bit and go ahead and give you the original coordinates. So N is at -3, -2. And W is at -3, -3. And F is at -2, -3. So we'll need that to rotate it. So it says rotate 180 degrees about the origin. So let's 180 degrees. Our rule is opposite X, opposite Y. So let's take all of our coordinates and change them to their opposites. So let's start with W. And W is at -3, -3. So it's going to be at +3, +3. And we can now graph that. Start at 0, 0, and always put a 0. If when the graph doesn't have numbers, put a dot at 0, 0, so you can easily find it and you don't have to keep looking every time. So right 3, 1, 2, 3, up 3, 1, 2, 3, and that is W prime. All right, N's at -3, -2, so both of those are going to change their opposites, so the new location will be at +3, +2. So start at 0, 0, right 3, 1, 2, 3, up 1, 2. And that is N prime. And for F, you're going to do the same thing. So F is at -2, -3, so that's going to become +2, +3. So start at 0, 0, right 2, 1, 2, up 1, 2, 3. And that is F prime. And now we have rotated at 180 degrees. Number 2. This one says 90 degrees clockwise. So our 90-degree clockwise rule is Y, then opposite X. And that is the order that we need to switch all of them into. So let's go ahead and list the original coordinates. So T is at -4, -3. N is at -2, -1. And V is at 1, -4. So we're going to use our rule, and notice it says quadrant. Oh, did I miss quadrant on the previous one? Oh, I did. The original one was in quadrant. Let's draw our C. It started out in quadrant 1, 2, 3, and it ended up in quadrant 1. All right. So this one we'll have to see where it ends up. All right. So new coordinates for N prime. I need little prime symbols. In prime, we're going to switch. The Y value comes to the front, so that would be -1. And then the -2 becomes +2 and goes into the second position. So graph that, -1. Oh, draw my 0, 0 so I can find it easily. Left 1 and up 1, 2. And that will be N prime. All right, for T, we're going to have -3 come to the front. -3, it stays the same but moves to the front. And then the -4 moves to the second position and becomes its opposite, +4. So let's now graph that. Left 3, 1, 2, 3. Up 4, 1, 2, 3, 4. And that is T prime. And the last one, for point V, we are going to take the the -4, move it to the front. So -4, comma, and then the +1 moves to the second position, becomes its opposite, -1. So the new location is -4, -1. So left 4, 1, 2, 3, 4, and down 1. And that's V prime. All right, let's connect our points here. And there is a rotation of 90 degrees clockwise. So if we draw our C, quadrant 1, quadrant 2, it ended up in quadrant 2. Awesome. Let's do another one. Number 3, a 90 degree counterclockwise. So on your table on the front, find the counterclockwise column and go down to 90 degrees. You'll notice it's at the very bottom of the counterclockwise rotation column. So that one is opposite y comma x. Opposite y comma x. So we're going to switch the y value to its opposite, move it to the front, and the x just moves to the second position. It stays the same. So the original coordinates here, we have 0, 4 for y, 4, 5 for r, and 3, 3 for m. All right, so let's find our new r prime, y prime, and our new m prime. Here we go. All right, so let's start with r. So the 4 is going to stay the same and go to the second position, and the 5 becomes its opposite, negative 5, and moves into the x spot. So negative 5, 4. All right, for point y, 0, 4, that's going to become, the 0 is going to move into the second position, and then 4 becomes negative 4, moves up to the front, the first position. For m prime, 3, 3, well, the y value of 3 becomes into the front and becomes its opposite, so it becomes negative 3, and the positive 3x moves to the second spot. So now we have to graph these and put my 0, 0 point to help me. So left 5, 1, 2, 3, 4, 5, and up 4, 1, 2, 3, 4. That's point r prime. Negative 4, 0, 1, 2, 3, 4, and up or down 0. So that's y prime. And negative 3, 1, 2, 3, positive 3, 1, 2, 3. And that's m prime. So now we have our 270 degrees clockwise or 90 degrees counterclockwise. Remember, those are the same thing. So which quadrant did it end up staying in? If I draw my C, I see that's quadrant 2. All right. Number 4, 180 degrees. This one's my favorite. So 180 degrees, that rule is the easiest. Opposite x, opposite y. Write your rule every time on your paper. All right, so I'm going to give you the original coordinates. So S is at 1, negative 2. P is at 2, negative 4. And R is at negative 3, negative 5. So we're going to change each of these to their opposites. So for R prime, R, negative 3, negative 5 will become positive 3, positive 5 and stay in the exact same orders because they don't switch places. For S prime, positive 1, negative 2, they both switch their opposites, so the positive 1 becomes negative 1, the negative 2 becomes a positive 2. So it's at negative 1, 2. And P, 2, negative 4, becomes negative 2, positive 4. All right, so let's graph these points. So 3, 5, I'm going to put my 0, 0, right 3, 1, 2, 3, up 1, 2, 3, 4, 5. And that's R prime. Negative 1, 2, so left 1, up 1, 2. And that will be S prime. And negative 2, 4, left 1, 2, up 1, 2, 3, 4. That one will be P prime. I connect my dots, or my points here. They're not really dots, they're points. And there we have a 180 degree rotation. Now, notice it's not a reflection because it is not mirrored. If we were to fold this paper along this line, the S and the S would not match up. So this, a lot of people confuse 180 degree rotation for a reflection, but it's not, because if we fold this paper, these S's are not being mirrored. They would not match up perfectly, okay? Because remember, for a reflection, you would count to the X, 1, 2, and away, 1, 2. It would have been over here. So don't get a rotation confused with a reflection, the 180. It is a little different. Always try to, if I fold the paper, would they match up or not? All right, we have 2 examples left. I want to quickly get through those. So if you will pause the video and give these a try on your own, then I'll go over the solutions with you. So at this time, I want you to pause it, and I want you to try number 5 and number 6 on your own. Number 5 is 180 degrees, so that one should be easy, and 6 is a 90 degree clockwise. It's really common. So let me help you with the rules. 180 degree is opposite x, opposite y. And I can give you the coordinates too. For v, it's at -3, -3. And for t, that one's at -2, -4. And r is at 1, 0. So that'll help you out to do your opposite and opposite. So pause the video now and go ahead and try that one, and I'll go over the answer with you. All right, you should have already tried this one on your own. So I'm just going to give you the solutions. So v is 3, 3. T is 2, 4. And R is -1, 0. So to see how you did. And the new quadrant, oh, I should probably graph it too. So 1, 2, 3, 1, 2, 3. 1, 2, 1, 2, 3, 4. And -1, 0. R prime. Connect my points. And now it's in quadrant 1. All right, let's move on to the second one, number 6. Let's go over the rule. The rule is y, comma, opposite x. If you look back at your chart, you'll see 90 degrees clockwise. Remember, so it's in quadrant 1, so it's going to wind up 90 degrees clockwise. It should end up somewhere down here. All right, so pause the video now and try that rule by yourself. Oh, let me give you the points. Sorry. V is 3, 3. F is 5, 2. And L is 3, 1. All right, now pause it. All right, if you are listening now, you should have already tried this one, so I'm just going to go over the answers. For V prime, it should be 3, -3. For L prime, it should be 1, -3. And for F prime, you should get 2, -5. And let's graph those to see if your graphs are right as well. So here's my 0, 0. So I'm going to go right 3, 1, 2, 3, down 3, 1, 2, 3. And that gives me V prime. For L, right 1, down 1, 2, 3. That's L prime. And the last one, right 2, 1, 2, down 1, 2, 3, 4, 5. And that's F prime. Connect my points. And there's your 90 degrees clockwise rotation. Hope you did well on that. All right, so that's a lot of examples you have. You have the front examples where we didn't have a graph and we just used our rules. And you have the back examples where we did them in a graph, but we applied our rules as well. So always remember a couple of hints is to find your rule first. So look back at your table, write it at the top, and then apply it slowly, just one term at a time, and then draw your graph. Okay, so let's look at your homework assignment. So your homework assignment is here, and it's a rotations practice. So it says, write a rule to describe each transformation. So 1, 2, 3, 4, they have done a rotation. They're all rotations, and they want you to tell what type. Was it a rotation 180 degrees clockwise? Was it a rotation 90 degrees clockwise? Was it 90 degrees counterclockwise? So if it's clockwise or counterclockwise, you should be able to write 2 answers, because remember, 90 degrees clockwise is the same thing as 270 degrees clockwise. So you could write that 90 degrees clockwise or 270 degrees counterclockwise. So your table and the front of your notes page should help with this. So you're just writing the rule for 1 through 4. On the back, you have 4 problems here that they want you to write the new figure on the coordinate plane. So they want you to do the rotation. So write your rule and do the rotation, and they want you to graph it. So that's what we'll be looking at tomorrow, is checking to see if you did the right graphs. And then the bottom part, there's no graphing. There's only 1, 2, 3, 4, 5, 6 problems where you're just applying the rule and writing the new coordinates. So you'll just list the new point like A prime, and give me the new location. So remember to write your rule for each, because they're all different. And then apply your rule and label with the appropriate notation. All right, so I hope this video has been helpful, and if you have any questions, you can message me in It's Learning, and I will do my best to get back to you. If not, I will see you tomorrow and we'll go over it. Thanks, guys, and hope you have a fabulous day.